Thank you very much for your company and welcome again to your channel Transmission Lines Engineering TV. We have previously described the areas involved in the design of and construction of a transmission line, and in this video we'll talk about the process or design flow for a project in a general way, since step by step we're approaching to the technical topics. Even it will sound some kind of weird. A transmission line project takes some years from the first proposal of the need for a new transmission line until its commissioning. To better understand this process, we can imagine something analogous to the water pipe systems in our homes. The way I'll explain this is in the way it is done in North America, but maybe it's not the way it's done in other countries, but it could give you some ideas so you can implement them in your respective countries. So let's see how they are. Number one, the alignment evaluation stage. In this phase, we will see the process that it is usually followed to achieve the final alignment of a transmission line. So as step number one, we have the client. The client, or owner of the transmission system, or owner of the house, is the one who operates the system or the pipelines in our house and observes the load density in different operation zones or water valves all over the house, and he will try to balance the energy flow or water flow from its generation facilities or from the water supply to its distribution substations or to the water valves all over the house as well. But sometimes the number of users or load increases, which is the same as a tub is going to be added, or a new bathroom will be added to the house, or maybe a second boiler will be installed and some other valves will be replaced. So in such a way that the transmission system or the pipes in the house becomes insufficient, and it is required a new transmission line, or we need to install an additional water pipe to feed the new bathroom, for example. The trajectory of the new transmission line is established by the client, who, before determining a final alignment, firstly will perform some studies with alternate alignments to affect as little as possible to the line owners and to have the smaller numbers of third-party permits, which is the same as having different trajectories for the proposed new water pipe to make the least number of holes on the walls or the shortest amount of material. As a step number two, once the client determines the possible alignments, it will be written the first document, which will serve as a basis to the engineering and construction consultants for its detailed design and construction. It will create what is known as a design basis memorandum, a DBM. This document describes the conductors to be used, the coordinates of the deflection points or PIs in the line, the structure types to be used, limitations for structures locations, the need or not of fiber optic, OPGW, etc. So it is like telling the plumber or contractor how to install the water pipe, the needs that we have, how much water we want to get from the new valves, or where we don't want holes to be made, and how to install the new pipelines, etc. The step number three, having the bidding rules or the DBM, the contractor will proceed to perform the detailed engineering, starting with the structure locations throughout the different alignments requested by the client. Once the structures are spotted on the paper, the client will contact the landowners where the structures are going to be located to request for their authorization to erect the structures in questions. Generally, affectation drawings or IOPs, individual ownership plans, are generated to show the landowner exactly where the structure will be located, how much surface of their property will be affected, and an explanation of the construction process. Step number 4. Parallelly to the structure's locations on each possible alignment, the contractor, through its engineering area, will obtain materials quantifications of structures, cables, hardware, OPGW, etc., and the construction team will determine their very own quantities, access roads, warehouses, locations, etc. The areas of engineering and construction will send their quantities to the purchase area to put together a price analysis to determine the approximate cost on each possible location or each possible route, and send the customer the cost of each one of them. As a step number 5, the client will inform the contractor of the final path to follow after having made the analysis of cost and permits of the final path. Once having the final trajectory, the client will compile the needs of each affected owner in a document which must be fulfilled by the contractor to ensure that the commitments made between the client and landowners are met. We could call this document a design restrictions document or red book. The stage of preliminary engineering phase. The IPCR, issue for preliminary client review. In this stage, it is described the process of the preliminary engineering development, which will be reviewed by the client for acceptance before moving ahead to the next step. The technical requirements are already done, the final alignment is ready, and the landowner's requirements are already defined. So, as step number 6, the structures locations previously made during the evaluation stage of possible alignments, it's reviewed again based on the design restrictions document or the red book to make the appropriate adjustments to the structure locations or structure heights and types. As a step number 7, the contractor will update the affected drawings to ownership properties or the IOPs to re-evaluate along with the owner and obtain the final authorization for the affected area. This includes not only residential or industrial owners, but also other infrastructure agencies such as railways, crossings with roads, pipelines, rivers, etc. So, to perform the detailed drawings and the calculations to obtain these permits, crossing drawings will be performed and will be seen in a different video. As a step number 8, at the same time, the contractor develops the documentation related to the details of the structures to be used, hardware assemblies, grounding systems, and generates the first material list to start the purchase process. There are many materials with quite long lead times such as structures, cables, hardware and fiber optic. So therefore, it is a good practice to start this process as early as possible to avoid last-minute rush. During this phase, the engineering area should support the buyers to put together not only the quantities but all the applicable specifications for each material. Step number 9. The buyer will begin to receive either questions from the suppliers or quotations. Something very important to mention here, and as a recommendation to our buyer colleagues, is the fact that the purchasing area must request the technical sheets for each material offer, including dimensions, weights, employed materials, and manufacturing specifications, since this is a key information for the engineering team to be able to carry out a proper technical evaluation of the materials quoted. Otherwise, there is a risk of accepting materials that are not completely suitable for our needs. Because of this reason, during the previous videos, it was mentioned the reason why the engineering area must support the buyer to determine the necessary information associated with the technical evaluation. The purchasing and engineering disciplines are like a marriage, until death or end of the project gets them apart. Step number 10. During the same process of material purchase, sometimes very specialized materials are required. For example, optical regeneration equipment, underground cables and associated accessories, or perhaps new structure suppliers, hardware or cables, and it's necessary that some of the members of the engineering team and quality must travel to carry out an inspection of the manufacturing and quality process. Let's go now to step number 11. The engineering area will assemble the first detailed engineering package for the preliminary review by the client. This package includes the necessary information such as project description document and design criteria, mechanical calculation of cables or catenary calculations, which is a key document that we will see later on in other videos, which if this document is wrong, let's all cry. Structures drawings to be used, hardware assembly drawings, grounding drawings, structure location drawings, detailed drawings for connections to substations, phase transposition drawings if required, foundation drawings, and as step number 12, the client will review this preliminary package for approval or comments to be made on some modifications. Step number 13. In parallel to the development of this preliminary engineering package, the project management area, with the help of the contracts, quality, environment, construction, and engineering, will begin to develop the document for the elaboration of the construction of the scope of work, including legal, financial, and technical aspects, so the future contractors can send their preliminary quotations. Once again, during the previous video, it was explaining the importance of the relationship between the involved areas. As a step number 14, the contractor will receive the approval and or comments or requests for design changes for the preliminary package previously sent to the client. So it is impossible to say how many changes usually are required. This is something very variable. The contractor, through its engineering and construction areas, will proceed to make the changes that will be documented with the support of the quality area. On the other hand, and regarding the structural locations, it is at this stage when preparations are made for the engineering team, supported by the construction area, to have a site visit to physically inspect each structural location to determine possible final movements. Those final movements will be made in the next package to be sent to the client. On many occasions, this visit is carried out jointly with the line owner. The next step, or the next stage, final engineering phase, which is called IFCR, issued for final client review. This phase does not yet refer to the construction package. It refers to the previous package, or our last chance to make changes by the clients, errors or omissions in our preliminary designs, etc. So in order to generate this package, it is necessary a site visit has been made to inspect each structure location point to have a final position. Step number 15. In this stage, in addition of the information previously sent in the preliminary package, more detailed information will be added. So right now we have the project description document or the design criteria, mechanical calculation of cables or catenary calculations, structure drawings to be used, hardware assemblies, grounding drawings, structure location drawings, detailed drawings for connections to the substations, phasing drawings, phasing transpositions, again if they are required, foundation drawings, but this time we're going to add staking drawings with dimensions towards property line limits, but not in XY coordinates. We will send as well sag and tension charts, optical splice box location engineering, assembly drawings and accessories for fiber optic (OPGW), dampers engineering, documentations for dampers positions or spacers, foundation drawings or special foundations designs, alignment drawings, crossing drawings, structure shop drawings, drawings related with access roads and location of work areas and positioning of materials at each structure location point, structure list, materials list, technical sheet of the materials to be used, like cables, hardware, OPGW and accessories, grounding systems, etc., construction specifications, quality formats to be used during the construction scope of work document. So this package should be reviewed not only by the engineering area, but by other areas such as construction, quality, environment, and contracts administration. As a step number 16, once the final revision package is finished, it is sent to the client for its last revision before proceeding with the construction. In the same way, final modifications can be received for its construction. The next phase is construction, what we call IFC, issued for construction. Once the final revision package has been received from the client, the contractor will proceed to make the final adjustments to the design. All this information will be documented in the previously planned quality system, and each document will be stamped and signed by the EOR, engineer of record, and will be put together to the construction package. Step number 17. The engineering area will place the stamp approved for construction and reinforce the package with documents with drawings completely sealed and signed. Step number 18. The construction and purchases disciplines will begin to establish the warehouses for materials reception and communication systems. Step 19. The project manager and contracts advisor will negotiate the final details for the construction costs with the subcontractors. Now, step number 20. The engineering department will establish contact with the subcontractors to give a detailed explanation of the project and the contents of the construction package. So it is advisable to have this kind of direct approach between the engineering team and the subcontractors, having the areas of project management and construction present in that event to provide a kind of tour on each document, especially those locations which would have special annotations on the drawings, and avoid confusions, or at least warn the subcontractors of those critical points during the construction. Step number 21. During this phase, the engineering discipline should be in close contact with the construction team, because during the foundation excavations, there are situations when it is necessary to move some structures from their original positions, and the presence of the design engineer is necessary to make changes, and some changes can be done remotely in the design office, and in many cases it is necessary the physical presence of the designer in the work site, and later generate modification to the drawings or defective drawings by means of the emission of new revisions, which should be documented in the quality formats. Step number 22. For each activity, the quality discipline will be vigilant to ensure that the subcontractor is working with the latest revisions of each document because of the modifications during the construction process. As a step number 23, once the construction is completed, or in those sections that have been completed, both the construction, quality, and engineering teams must perform the line commissioning to review that the works were developed as indicated in the documentation. The step number 24. During the construction process, all the modifications will be registered with a color code on the drawings and documents, which will make up the so-called red line package for this subsequent shipment to the construction and execution of the as-built package and the closure phases as-built. Once the construction and commissioning have been completed, the acceptance phase by the client proceeds. As a step number 25, the client will also carry out a revision not only in this phase but in the whole construction process phase, and grant the construction acceptance in a partial way for those completed sections. The project and construction management will review together with the client the final construction status and satisfaction for the final acceptance of the entire constructed project. Step 26. The engineering team will review the red line package jointly with the construction area for the proper understanding of the annotations and their correct modifications of the affected documents. The documentation generated for this package must have the legend and seal as constructed. With this information, the as-built package containing all the technical information used for the project is prepared, which will serve the client for its own database or future consultation or future connections with other lines. Step 27. The quality areas will check that the areas of construction and engineering have the totality of the quality formats duly documented, and for the quality package, which is the history of the project construction, including not only formats but visual references such as pictures of each structure, as well as cable installations, grounding systems, OPGW, etc. Step 28. The engineering and quality disciplines will assemble the final delivery package to the client with the aforementioned information. So, as you can see, the design and construction process is quite complex and requires an enormous efforts of coordination, repeated actions, decisions making, and negotiations with other third parties during the process. In the above explanation is presented in a way as easy as possible for your understanding, but in reality, despite having these plans from the very beginning, it is not a guarantee that everything will go according with the plans, since there will always be setbacks that affect the project progress. I wish it will be as simple as it sounds, but unfortunately it's not. The intention of providing this explanation is to somehow help those who watch this video to determine the need to consider to improve their design processes and construction as well in the transmission lines. Surely each country has its own process. I cannot know all of them, but at least I hope this information is helpful for you. So thank you again for your visit to this channel. Don't forget to subscribe and limit your comments. So see you on the next video. Transmission Lines Engineering TV, training to power the world.